Good morning, everyone. I am M. Penisha, Assistant Professor in the Department of Electronics and Communication Engineering at JPR Institute of Technology. And my project mates are Gautam Goban from SRM IST Ramapuram and Dr. Mithilesh Satyanarayanan from MIT Square, London. I am here to present the challenges and opportunities of using artificial intelligence in detecting and identifying exoplanets. We all know that exoplanets are the planets which are away from the 8 to 9 planets which we already know, which are rotating our sun. The availability of exoplanets, when we know in the ancient days, it became very popular for the astronomic scientists. There are so many research are going on in finding, detecting, analyzing the exoplanets in the astronomic scientists. The detecting the exoplanets and their habitability and the possibility of extraterrestrial life is a very important research which is going on as a trending one nowadays. There are multiple prediction methods and the detection methods are available for finding the exoplanets in the galaxy. But we need a very excellent technique to predict and detect the new exoplanets. We know that in recent days, artificial intelligence plays a very vital role in predicting the possibility of different things. So we are applying the same deduction using artificial intelligence for the exoplanet also. So in this presentation, we discussed shortly a very short survey and the overview of opportunities and challenges of using artificial intelligence in detecting the exoplanets. First, let us discuss about the various present exoplanet detection methods which are available. The first method is the transit method, which is a very ancient method. So in this one, the exoplanets are identified by the brightness variation. When the exoplanet is crossing a star, there will be a dip in the brightness of the particular star. So by continuously monitoring the brightness of a particular star, we can analyze and we can find out the exoplanets which are orbiting around the star. The next method is the radial velocity method. It is also called as Doppler method. Here, analyzing the periodic shift in the star spectral lines which is caused by the gravitational tug of an orbiting planet, we can easily find out the exoplanets which are orbiting around the particular star. And the third method is direct imaging. By using different kind of satellite and the satellite telescopes, we can capture the actual image of exoplanets by taking the picture of a galaxy. But from the picture of the galaxy, we can identify the presence of exoplanet and the constellation of the particular exoplanets and their composition. The next one is microlensing. Microlensing is a gravitational effect that occurs when a massive object such as star or planet passes in front of a more distant star. By using this phenomenon, when the particular exoplanet is orbiting around a star, there will be a gravitational variation. By analyzing that, we can identify the presence of the exoplanet. And the next one is astrometry. Astrometry involves measuring the precise position of a star over time. This is applicable for the massive planets. The next one is pulsar timing. So it is a method which is to detect the exoplanets by monitoring the precise timing of pulses from rapidly rotating neutron stars. That is called pulsars. By measuring the variations in the timing caused by the gravitational pull of an orbiting planet, we can identify the presence of exoplanet around a particular star. Next one is TTV and TDV, which are nothing but transit time variation and transit duration variation, which provides the opportunity of analyzing the variation in time and duration of exoplanet transit. So this is the derivative of first method, transit method. And the last one is the follow-up spectroscopy. So after initial exoplanet detection, we will be applying follow-up spectroscopy method for finding out the exoplanet's atmosphere so that we could check whether there is an life possibility is available in the exoplanet or not. Here we are going to see how AI is used in the detection of exoplanets by providing the input data such as time series data, Kepler data, transit properties, hyperparameters, transit equation, start equation and functions, transit observation and non-transit observation. All the informations will be given to the input to the machine learning or deep learning algorithms which is working inside the artificial intelligence method. By different regression techniques, so we will be finding out what are all the things we can able to match, and it will provide an output. From that we can able to detect the exoplanet. And next is the challenges of using AI in exoplanet detections. So we know that the atmosphere of the galaxy is not a constant one. So it is a keep on changing things. So we cannot expect the data to be a perfect one. So there will be a 90% of possibility of having data variability. And in the case of artificial intelligence and machine learning, we must have hundreds of data samples to train the program. So there will be a data volume problem in the complexity of data. And in some of the cases, there is the limited data will be available. So that is also a challenge. And a proper signal detection, and sometimes we will not get the proper data. So that is called the false positives. So, and sometimes there will be a problem of overfitting, and interpretable models must be prepared for detecting the exoplanets. So, and sometimes we may find there are some computational inefficiency is found on the system when applying the artificial intelligence. So, in some cases we could not able to achieve the maximum efficiency when the AI is applied with limited amount of data. So, and when we are applying this, we must take care of the ethical consideration also. And the artificial intelligence model which we are going to apply must suitable for integrating with the existing methods. Even though there are so many challenges, so it is providing so many opportunities to work on AI for the detection of exoplanets, which will improve the efficiency, sensitivity, and automation, and collaborating with scientific people and public engagements, and reducing the human bias, machine-driven hypothesis, and the extended services like real-time detection, adaptive techniques, optimized resource allocations. So these are all the advantages or opportunities we can have. And at the conclusion, the rise of artificial intelligence in exoplanet detection possesses both obstacles and potential. By analyzing the vast amount of statistical information more effectively and correctly, we can achieve the best AI method for detecting the exoplanets for irrespective of the galaxy atmosphere. So there are massive data which we can get from the satellite and satellite telescopy about the exoplanet. By properly monitoring and making the training data set and the AI algorithm, so definitely we could able to achieve a best AI algorithm for detecting the exoplanet as well as its atmosphere for the possibility of habitability in exoplanets. The effort to search for exoplanets is about to enter into an exciting new phase of discovery. So definitely AI will be a part of this particular journey, and will definitely find out that so many different exoplanets which are in and around our solar system. So I hope the session is little bit interesting. So, and you can also start your research on creating an AI algorithm for detecting an exoplanet. So thank you so much for listening. Thank you.